So in this video, we're going to graph two functions, the sine curve as well as the cosine curve. So let's start off with the sine wave. And let's recap what sine means in regards to how it's related to a circle. So here we have a unit circle where the radius is 1. And we're starting at the initial arm of 0 degrees. And then what we're going to happen is we're going to move this initial arm all the way around. And let's recap what sine means. Sine has a choice. It's either the x or the y value of the unit circle. And in this case, recap that sine refers to the y value. So put here, it refers to the y value. And just to recap the 5 special numbers in regards to the special angles, remember 30, 45, and 60 degrees. We have 0, 1/2, root 3 over 2, 1, and the one in the middle is root 2 over 2. And for the decimal places, just to get a sense when we start graphing, it is 0.5, 0.7, and 0.86-ish. So I want you to think of a, let's put an application context to this when graphing. I want you to think of this unit circle as a water wheel or a Ferris wheel or some sort of wheel that turns. And I want you to think of the x-axis as the water. And I want you to think that right over here is where the ride begins. And when the ride starts, you're going to go counterclockwise. So meaning this red dot here is going to go all the way up in one big revolution back to the initial starting point. So let's imagine, as I said, let's imagine the x-axis is the water. And here's the red dot starting at the 0 degree position, initial arm. And let's assume that the ride starts and moves counterclockwise. And if you notice here, we are tracking the sine value. And remember what the sine value means? It is the y value of the red dot. And in this case, we're tracking the blue dotted line here. So let's have a look here. At 30 degrees, what is the y value? Or how high is that red dot from imagine this as the water. So over here, oh, it's 0.5. Remember that 0.5 is one of the special angles related to 30 degrees. And as we keep on going, what happens? It go to 45. 45 degrees is going to be 0.7, which is root 2 over 2. And then we keep on going. So as you can see, as this red dot or the red goes around the circle, it's above the water and or the x-axis. And if over here, the maximum height this ride reaches from the water is going to be 1 when it's 90 degrees, and you keep on going. What happens to the ride or the blue line, the distance of the blue line with respect to the water or the x-axis? It is right now decreasing. And then we keep going at 180 degrees. So right now the terminal arm has moved 180 degrees. Where is it right now? It is on the water or on the x-axis. But what happens after 180 degrees? Because half the ride is over. Well, right now, imagine this red dot, it is below the water. And that's why we have the blue line being negative. See, negative 0.4, negative 0.5, negative 0.6, negative 0.8. And what's the deepest that this red dot or this ride will go? Well, at 270, the most lowest point that this graph will go, or the ride will go, the red dot will go, is negative 1 below the water or the x-axis. And then after that, what happens after that? It seems like you're getting closer to the surface of the water level, or in this case, the x-axis. So what we're going to do right now is I'm going to show you the actual sine curve, the sine function, based on what I just mentioned about in the previous slide. So here is a blue dot, the blue terminal arm or initial arm, and we're going to move it counterclockwise 360. So I'm going to drag the slider and move it 3.20 degrees. And what happens? We're going to track the height of the red line, which is the height from the x-axis, or you can think of as the height of the P point from the water. So it seems like the point is getting higher, and over here you're reaching the max. So let's have a look at the right-hand side. So notice the curve has gone up. And I'm going to continue on. What happens after 90 degrees as I approach the 180 mark? Oh, it seems like the ride is going down, and right now we're at the water level or the x-axis, but after 180, what happens? You are below the water or below the x-axis, and notice the red part on the right-hand side, it's dipping low, low, low. And how low do we go? It seems like the lowest point here is going to be negative 1. The most you can go, or the ride will go 1 below the x-axis or the water. And then after the 270, what happens? The ride or the red line is getting getting shorter from the x-axis, and it's going to go back to the surface. And right now, this is considered one cycle of the ride. If I keep on going with this, for example, if I keep on going with the ride, what's going to happen is the ride is going to extend. So imagine the ride going more than one circle or more than one cycle. What's going to happen is the following. So I wish I had this here. Imagine this here. I'm going to extend, and it's going to actually keep on going. But we only have one cycle here. So here is one cycle of the sine curve. And in this case, let's analyze the graph. So what is the equation of the axis? So these are the features that we talked about in earlier parts of the unit. So the equation of the axis is the horizontal line that cuts the graph in half. And in this case, the horizontal line I'll use in blue would be over here. So I'm just going to draw in dark blue. This is we call this the equation of the axes. So we're going to call this, there's a name for it, an equation for this, because we need to find the equation of this blue line, which is y is equals to 0. What is the amplitude? So another word is amplitude. And recall that amplitude is the distance from the maximum to the equation of the axis. So I'll put in also in green, so this part here. So there's my maximum. I'll put here maximum. And there's also my minimum is over here. And the distance between the maximum and the blue line, or the equation of the axis, in this case is going to be 1. Same thing for here. The distance between the blue line and the minimum is also 1. It is not -1. Keep in mind, amplitude is always positive. So that's the amplitude. Let's have a look at the period. So the period of the function is the horizontal distance of the cycle. So I'm going to use a black pen here. So from here to here, so one cycle means one circle rotation is from here to here. So it starts from 0 all the way to 360. And then notice here the extension. I mentioned that if I were to go on another rotation of the ride, I would have to go back up and then back down. So this here is one cycle. Over here is the start of the second cycle if the ride were to continue to rotate. So in this case, the period is the width of one cycle, which is from 0 to 360. So it's going to be 360 degrees. So let's talk a bit about the cosine wave. So previously I mentioned the sine wave. Think of this as the water, and we are measuring the distance of the ride over from here to here for the sine wave. But the cosine is different, because remember that cosine doesn't refer to the y value. It refers to the x value. So we're going to look at the distance of the dot from here, from the edge of the circle, to the y-axis. And then let me put a context into this. I want you to think of a ride, like a rotational Ferris wheel or some circular wheel ride, but we're going to measure something different here. I want you to imagine a helicopter right here. So here's a helicopter. And imagine a string going down. So this string here is my y-axis. And I want you to think that, let's just say you are here. And I'm going to actually give a twist to this, meaning we're going to measure the relative distance of you as you go around the circle to the string. So in this case, right now, you are to the right of the circle. But what happens if you keep on rotating? Over here, you're to the left of the circle. If you're to the left of the circle, the left of the string going down, you are actually negative. So anything to the right of the rope is positive. Anything to the left of the rope is negative. So let's actually look at this cosine graph. Well, let me describe how the cosine graph is going to start. So imagine that little blue squiggly line is the rope or the string from the helicopter. And what we're going to do is we're going to take this ride here, see the dot there? And we're going to rotate this. So right now we're going to follow how far you are, or that dot there on the edge of the circle, how far it is from the rope. And right now, everything here, what's happening here, we're to the right of the rope. That means we are positive. For example, we're going to be looking at the x. So right now we are 0.96 away from the rope. Now as we go up, we're getting closer to the rope. So it's going to be 0.8 right now. As the angle gets more, it seems like we are getting closer, really, really closer to the rope. And that number, 0.35, 0.34, is getting smaller. And right up to here, what's happening at 90 degrees, we are at the rope. there is no distance between that dot and the rope or the y-axis. But when we go past it, what happens? Well, notice how the x values is negative. The reason why it's negative is because we are getting further away from the rope right now, horizontally, but we're to the left. So when you're to the left, you're negative. So anything here, we're negative, and we're getting very far away. So we're going to track that red dotted line. And over here at 180 degrees, when the half of the ride is over, we are at the furthest away from the rope, the string that's on the y-axis. So we're -1 to the left. And if we keep on going in the ride, so we are below the x-axis, but we don't care whether below or above. We just care whether we're to the left or to the right. So right now we are still to the left of the rope, and we're going to get closer to the rope, until we are, so now we are 270 degrees around the ride, and now we are at the rope, and after that we are to the right of the rope. So now we have positive, we're positive. And right now, for the next slide, we're going to see what the cosine graph looks like based on how far we are from that vertical axis or the rope. So here we're going to track how far that P dot, so right there, that P point, how far it is away from the y-axis. Imagine the string going down. So at 0 degrees, it seems like that P point is the furthest away. It's actually we'll call it 1 meter away from the y-axis. So what I'm going to do, what happens is, over here, notice the graph. So the graph is starting. Notice how the graph starts at 1 and it sort of dips down. Well, the reason why it dips down is because the P is actually getting closer to the y-axis, or we're getting closer to the string or the rope. And at 90 degrees, we are actually at the rope. See that P black dot? We're on the y-axis, we're at the rope. And if we keep on going to past 90 degrees, we are to the left. So we are to the left of the rope or the y-axis, and the furthest we'll get from the rope is at 180 degrees. So at 180 degrees here, we are at the furthest 1. That's why -1 is the most farthest you'll get from the rope. And as we keep on going on this ride, we're going to get closer to the rope, and notice the graph is right now on the x-axis at 270. And after that, so what happens? We're going to finish off the ride. We are to the right side of the rope, or the right side of the vertical axis. And when we come back, and then we're going at 360, we come back to where we began. So here we have one cycle or one revolution of the wheel or the circle of tracking the cosine, tracking the x values of the circle of the terminal arm. So if you notice here, we'll actually analyze the key features. So we have a maximum of 1. So here, over here, is my max is 1, but my minimum is also -1. Very similar to the sine wave. What's the middle point? So what's the equation of the axes? So if you're not sure in terms of visually seeing this, what you could do is we could actually take the max and the min, add them together, and divide it by 2. We can take 1 plus -1 divided by 2 is equals to 0. So we're finding the average between the max and the mid. So in other words, this line here that I'm drawing in blue, this is also my equation of the axis. We'll call it y is equals to 0, very similar to the sine wave. What is my amplitude? Again, amplitude means the distance from the max to the equation of the axis. In this case, it's going to be 1. If you're not too sure visually, you can actually calculate this. There's actually a way to calculate this. We can take the maximum minus the minimum divided by 2, or 1 minus -1 divided by 2. That gives us 1 plus 1 over 2, which gives us 1 at the end. So it really depends on how you want to calculate this, visually or mathematically using numbers here. And the last one is, what is the period? Well, the period, this is the start of the cycle. This is where we started, and this is where we ended. So a cycle is how far you are from the beginning, horizontal-wise, to where you began. So this is my beginning, and this is my finishing point, because I started off here, and I ended off where I began. So from here to here is my period. And if I were to extend this graph here, I'm going to use a black marker here. Imagine the ride keeping on going. So I would have to take this, extend it, go lower, and then go back up. It would be better if I had a better scale. Or sometimes I can actually extend it to the left, meaning this bump has to go down and then keep on going over here. So I will teach you in the next video of how to graph more than one cycle. Because at the moment, this blue part here is actually one cycle. Over here is, let's just say 75% of a cycle. This one over here is maybe like not even half a cycle. So you are responsible to know how to graph one cycle for now of the basic sine wave and cosine wave. So let's just recap sine waves. Sine wave, we know that in both case cosine and sine, it starts at 3 and 0 to 360. That's one cycle. However, the sine wave starts off at the 0 degrees. It has an upper bump. It goes up and then down. So imagine the ride going up and down. So this part here is you're above the water halfway through the ride. And then the second half of the ride, you are below the water, below the x-axis. So this part here is 360, halfway is 180. And at the very peak, you are a quarter of the way, that's 90 degrees. And over here, you are 3/4 of the way through the ride, so that's 270. Now I'm going to graph in blue the cosine wave. So the cosine wave. Now the cosine wave does not start at 0 degrees. At 0 degrees, it actually starts highest. It starts right over here. And it ends off at 360 over here. And the question is, well, what's happening halfway? Well, the halfway mark over here, the cosine wave is at the lowest. That's at -1. Oops, or at -1, right over there. And I'm going to connect the dots. And when you graph, there has to be symmetry. So over here, I'm going to go down. I'm going to pass over here, 90. Here's my -1, and these are +1. And over here, I'm going to go back to 270, and I'm going to go back up to 360. So remember what cosine is? Cosine is how far you're away from the x-axis. And that's why over here, I'm positive. So over here, there's positive. But when I'm over here and over here on this side, I'm all in the negatives because I'm to the left of the y-axis. And over here, when I'm finishing off the last part of the ride, I am to the right side or in the positive part. So if you notice, if you look at these two graphs, they're kind of similar in the sense that they have very similar, I'm going to call them bumps and valleys. So if you notice this part here in yellow, there's an upper bump and there's a lower bump. And in the cosine wave, there's a lower bump right over here, but there's a half a upper bump and half a upper bump. And these bumps, I'll call them bumps or we can call them valleys or peaks or valleys. They are the same size. So if I were to draw this perfectly, this bump here, right over here, if I were to actually take this and cut it out, it actually should overlap the bump here. So the bumps have to be the same size, same height and same width in regards to symmetry. So in the next video or next video, I'm going to show you how to graph transformations, meaning, well, what happens if I don't have a unit circle? What's going to happen to the circle? Well, the circle will be bigger. Well, how's that going to affect my graph here? Will my graph be bigger? Yes, your graph is going to be bigger to some extent. Or what happens if the ride has a different shape or different size? Oh, well, will my graph be different? Yes. So in the next video, we're going to do transformations.